Good day everyone, I'm Teacher Lab and welcome to Science 10.
So this video lesson is intended for Science 10 Quarter 1, Week 1 to 3 with the lesson Volcanoes, Earthquakes, and Mountain Ranges. Before we start, let us first know what is our learning objective for this lesson. Describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory. So for now, let's have a review first. Do you still remember your discussions during your grade 6, 8, and 9 about volcanoes and earthquakes? So for now, I'll be giving you some definitions on which you're going to analyze or identify the exact terms in just completing the word itself. A big body of land on the globe. 10 seconds. Okay, and the answer is continent. Let's have the third one. A chain of mountains. Another 10 seconds. And the answer is mountain range. Next, a vibration of Earth due to the rapid release of energy. The answer is earthquake. And lastly, we have a measuring instrument for detecting and measuring the intensity and direction and duration of movements of an earthquake. What would it be? It is seismograph. So based from our review, how many terms do you have remembered? Did you answer it all correctly? Okay, so let's proceed now to our topic, the Earth's lithosphere. So what is a lithosphere? The lithosphere is the rigid outer part of the Earth consisting of the crust and upper mantle. So this is where the lithosphere can be found. And when we say rigid, it means that it is somewhat hard and brittle, meaning it can be easily to break. Then we have crust. Crust is made up of a variety of solid rocks like sedimentary, metamorphic, and igneous. It has an average density of 2.8 grams per cubic centimeter and its thickness ranges from 5 to 50 kilometers. It has two types, the continental crust and the oceanic crust. So what is the difference between the two types? First, when we say continental crust, it is found under large land masses or continents. It is older and thicker, and it is made up of granite rock. While, on the other hand, when we say oceanic crust, it founds under the oceans, it is younger and thinner, and it is made up of basalt rock. We have here the plate tectonics model. If you notice, according to this model, the Earth is not composed of a large land mass, but it is separated or broken down by segments or pieces, which we call the plates. So how did it come up to this type of model? So it is according to the plate tectonics theory. Plate tectonics theory is the grand unifying theory in geology. This theory states that the Earth's outermost layer is fragmented into a dozen or larger and small solid slabs called lithospheric plates. It means that the Earth's crust is broken into segments or plates that move slowly but constantly. Now, as an effect of the plate tectonics movement, it produces volcanoes, earthquakes, and even mountain ranges. So for now, we will first tackle about the volcanoes. We have here the map of the active volcanoes. As you can see, those who have the red triangles are the ones which are active since 1900s, while those who are in the blue triangle are volcanoes which are active in the Holocene period. So as you observe in this map, it shows that volcanoes are distributed unequally on the Earth's surface. There are some which are being concentrated, on which you can see that some areas have many volcanoes, while others are completely lacking. So what do you think would be the possible explanations for the distribution of these volcanoes? So this distribution characteristic has been correlated with structures of almost global proportions as well as those with purely local geologic conditions. So here are examples of the volcanoes here in the Philippines, which we can find in any area from Luzon, Visayas, and Mindanao. Another highly visible feature of the global distribution of volcanoes is their concentration around the margin of the Pacific Ocean, forming the so-called Ring of Fire. So you are familiar with this Pacific Ring of Fire, right? So 75% of Earth's volcanoes, more than 450 volcanoes, and 90% of Earth's earthquakes occur along its path. So the abundance of volcanoes and earthquakes along the Ring of Fire is caused by the amount of movement of tectonic plates in the area. So this is where the common places which volcanoes and earthquakes occur in the Pacific Ring of Fire. Next is we have the earthquake. So here are some images of earthquakes which happens in the Philippines. So earthquakes can cause huge amounts of death and destruction. The epicenter is the point on the Earth's surface vertically above the hypocenter or focus point in the crust where a seismic rupture begins. So how can earthquakes be detected? So we have the seismograph and the seismogram. When we say seismograph, it is the earthquake monitoring instruments which record the seismic waves of the earthquake, while seismogram is a record made by the seismograph. So this is the map of the earthquake epicenters. So as I said earlier, this area is where earthquakes usually happens, and this area is called the Pacific Ring of Fire. So earthquake epicenters. The world's earthquakes are not randomly distributed over the Earth's surface. They tend to be concentrated in narrow zones. Majority are located near the edges of the continents. Some are in mid-continents while others are in oceans. But not all edges of continents, mid-continents, or oceans can be places where earthquake might occur. So we have here some tips on which what you should do during an earthquake. So the common is the drop, cover, and hold on. So as you remember on our face-to-face classes, we have an earthquake drill on which we have done such activity, and afterwards we evacuate to a safe area. And then another is we should calm down. We should not be in a panic mode for us to think well on where to go or where is the area on which we feel that we are going to be safe. Next, if an earthquake happens and then you are inside your house or in a building, what you should do is to stay away from furnitures, windows, and lamps. In short, you should stay away to the things which might hurt you or injure you. And then, if you happens to be outside, then what you're going to do is you're going to stay away from buildings, from walls, and from power poles. Because during an earthquake, it could be that it can be shaken and fall off. Next, what will you do if you are driving? So, if you are driving, you should stop in a safe place, turn on the hazard lights, and stay inside the vehicle. And the next is, when the earthquake stops, then you should go out to your vehicle and find a safer place. Next is, if you use a wheelchair, so this is for those who are persons with disabilities, put the brakes on in a safe place and protect your head with your arms. Next is, if you are in a crowded place, protect your head with your arms or take cover under seats and tables. Lastly, we have the mountain ranges. What is mountain ranges, by the way? So most mountains and mountain ranges are parts of mountain belts that have formed when two lithospheric plates that move towards each other, and where in most cases they continue to move towards each other. So because of possibly an earthquake, it moves towards each other, in which it forms mountain ranges. So in effect, many mountain belts mark the boundaries of lithospheric plates, and these boundaries in turn intersect other such boundaries. So this picture shows an example of the mountain ranges in the Philippines. So mountain ranges are found in places where volcanoes and or earthquake epicenters are also located. So this is the map of the mountain ranges, and as you observe, to which area, that it is also where the Pacific Ring of Fire belongs. So to sum it up, here are the three maps on which it shows the volcanoes, earthquake epicenters, and mountain ranges can be found. So what have you observed? So with these three images, we can see that volcanoes, earthquakes, and mountain ranges happens or can be seen along with the Pacific Ring of Fire and on the edges of the plate boundaries. So why do you think they are located along the plate boundaries? It is because along with the plate boundaries, the plates are moving, and such movement makes them to interact with each other, which results in affecting each other. When the plates are moving, it causes the shaking of the earth, and in which it produces earthquakes. If the plates are moving, the magma or the molten rock besides it can be disturbed, on which it comes out in the form of volcanoes. And when the plate is moving, it pushes each other, on which the land moves upwards, and it creates mountain ranges. So hope you have learned a lot regarding this lesson. So that would be all. Thank you and God bless.